There are several different means available for detecting nuclear radiation. And of course, it's very important to be able to detect nuclear radiation, given that it can be harmful to tissues, and we'll talk more about that in this lesson later on. But the three main ones that we'll talk about for detecting are photographic chemical detection, Geiger counter detection, or scintillation detection. So in the first one, a photographic or chemical detection, this works the same principle as old photographic film. So the idea is that there's a chemical that can be broken up when it interacts with a radiative particle, an alpha, beta, or gamma particle. And then that chemical can be later exposed to create, like we did with photographic film. So, and again, photography is one of the first ways that these high energy particles were detected, again, accidentally. But you can use that same technique to create detection. So if you work at a nuclear power plant, for instance, you might have a badge on that has one of these chemical detectors. Now the badge is usually protected, so visible light doesn't trigger these chemicals, but higher energy radioactive particles can. And if your badge gets a large dose of radiation, meaning you get a large dose of radiation, then the badge chemically will react, will alter, indicating that you've received a large dose. So usually it's a little colored symbol on the badge. If it turns a certain color, usually black, that means you've received a high dose of radiation. Geiger counters work by having a tube of rarefied gas that when a particle, usually beta or gamma, because alpha have difficulty getting into the tube in the first place because they can't really penetrate the outer wall. But when a radioactive particle interacts with the rarefied gas, it can create an ion, excite it, which then allows that ion in this electric field to run into a plate and click. So a Geiger counter, you'll hear, if you've ever watched a TV show with radiation, they usually like to use Geiger counters because you'll hear the clicking of the presence of radioactive material. Now, radioactivity is around us all the time. Some of the air in this room is radioactive. The rock in the walls, some of that material is radioactive. If you eat a banana, it has radioactive potassium in it. So this radioactivity is all around us. The Geiger counters always show a low background signal. And I'll have a video up here to show you the clicks that you would hear for a Geiger counter as it's detecting radiation. So that's probably the most famous example of how to detect radiation. Then finally, the last, your book talks about scintillation detectors. Now, scintillation detectors work on the principle that when a high energy particle emitted from a atomic nucleus, like an alpha, beta, or gamma particle, interacts with certain materials, they can excite the electrons. So an alpha particle comes in, hits an electron, that electron gets excited, or hits a beta particle comes, hits the electron gets excited, and can cause fluorescence. So light will then give off, as that electron falls back down into lower energy levels in the atom, it gives off light, we can see that light. So scintillation detectors work by showing little flashes of light where the high energy particles hit. And I'll show a quick video here of what a scintillation detector would look like. Just faint little pops of light, faint little emissions of light due to the interaction with these radioactive materials. So we have these three main ways of finding the presence of radioactive decays, radioactive nuclear reactions. Without these, right, they're going on in the room around me, I wouldn't know that they're occurring unless I had some way to measure these reactions.